Okay, so I would rather do this driven by the public, but just to kind of warm things up, I do have a few things prepared that are basically out of the presentations. So let me start with one topic that kind of came up pretty often, that is this concept of contextualization of what you're doing, which is certainly a very important thing to keep in mind. But I'm going to tell you a little bit about my own personal history with this. So I tend to work a lot with both biologists and social scientists. And something that has happened more than once is, you know, you have some results, you're very excited, you go talk to them, and they tell you a story about why those results make sense. Then you go back and you see, oh, damn, I reversed something, and now it turns out that the story doesn't fit anymore. You go back to them, and they will be, oh, great, then the story is. So there is a classical difference between data, so using data analysis to generate hypotheses, and confirmatory analysis, right? And I think that one of the issues, at least personally, that has happened over the last few years is that that line has blurred. And we tend to think about procedures and methods that technically would be used only for generating hypotheses that then need to be confirmed by further experiments, with things that are confirmatory that we can just go out and use as if they were true. So do you guys have any thoughts about the challenges of contextualization given kind of that pattern where the scientific method in some sense has been evolving in a way that may lead to non-reproducible results and not applicable results?
I'll take a stab at it. I think one of the issues with trying to confirm data that's learned from models, especially automated models, machine learning models, is that the way it's confirmed right now is it's foisted upon society in some way. And then we learn if it fails if there's an issue or someone makes an outcry. So given that the application of some of these models are to all of social networking or tracking all people on a campus. So it sounds like what some people are advocating, maybe what Jody was advocating was, you know, ways to test it ahead of time, a way to have sandboxes where you can see the results before foisting it upon all of society. I don't know if that answers your question, but it seems like there's something different about the nature of machine learning where you're learning directly from the data in a way where the model's tunable in a sense, but it's also uninterpretable when you tune it. So I don't know if anyone wants to follow up on that.
I mean, I guess all I would add is I think if you have, I don't fully understand the conversation that's happening right now, but what I would say is if you take that data set and then you add an ethical imperative on top of it, you better do some testing before you roll out both the data and the ethical imperative, because it's like if I look on Amazon and as usual it is proposing movies for me that are totally inappropriate for me, there's not an ethical imperative that says you must buy this movie. Right? But if we have all this data coming about student mental health and we have an ethical imperative that says if we know that certain activities in the classroom, really interesting, right, help students with mental health, then I'm going to tell you who they are and you're going to go and help them. We would definitely want to, I think, be cautious in that.
Just to challenge the Netflix recommendation, I heard a recent story, I don't know how true it is, but they recommended how I committed suicide, or 20 reasons to commit suicide, and indeed there was a spike in suicide after that became available on Netflix. So recommending something which is dangerous, I mean, I think people should freely be able to choose whatever media they want, but there could be issues, especially with children or teenagers or people at risk.
I am very familiar with this problem because I often am using sort of repurposed data or legacy data that, you know, you are trying to find a pattern in it, and you know, people start saying, oh, you're data dredging, or you're doing on a fishing expedition, or something like that. And I think that one of the ways that I sort of like, speaking of like anxiety, like calm my panic about that is like this idea of triangulating, and you know, in a mathematical sense, that's like using multiple points to look at, you know, to locate something. But in a social science sense, it's usually meant to mean bringing like different types of data sets to bear on something. So I feel like I actually like some of the aspects of predictive sort of learning where it's reporting back to you like these things are important in predicting this thing, just at a very like phenomenological or like kind of raw, like we don't know why, but it's predicting that. But then you need to look outside that data for, you know, insight into why that pattern might be there. And I know you're saying that, you know, and I've been that psychologist. Oh yeah, you know, you can like, I see why it's like that. And I remember that being a mathematician theorist in a physics joke about, turn the graph upside down. And so I feel like I can't think of a good way to address that except to get more different kinds of data from more different kinds of people to try to, and to be talking about mechanism, right? I mean, don't just look for patterns, like look for what do you think the process is. Talk to other people about what they think the process that gives rise to that data is. I feel like that's kind of the angle that I take on it. Okay.
There was a question from the public up there.
I think sort of thing. So in your last slide, you said that that fairness is more of a ethical consideration rather than a statistical consideration. And I'm wondering, is there any formal methodologies for analyzing an algorithm to rate its fairness, or other than just kind of looking at it and going, well, it doesn't seem fair, or waiting for the New York Times to report on it? Are there other approaches to that?
Right. Yeah, that's a great question. I used to have one slide, but I just didn't have time to include that one. Right now, you can imagine there's so many papers pumping out about fairness in machine learning, and there are more than 20 definitions for fairness in machine learning, and they're all statistical definitions, and which no one knows which one is fairer according to people's perception. So I think they're definitely a very, very interesting question, and I think, as I mentioned, it requires interdisciplinary collaborations, and I think this is a very good topic in this area called HCI, human-computer interactions. When we are translating these societal questions into machine learning, but then to close the loop, we should really push the question back to human to let people tell us, or to let people make a judgment about which definition is preferred, or which definition is likely to be the most convincing one. Right? I think that's a great question, but I was aware of some recent works, but it's still very, very preliminary. People still don't know where we are going.
And maybe for different definitions for different applications too.
That's a good question. So people have been talking about maybe this is a personalization question. You want to, or context question. You want to put different definitions into different applications to make them the best fit to each other. Right. But there's also, this may also open the possibility of gerrymandering, this type of things. You can do manipulation to make it look fair, but then it's not really. Yeah. So.
Another question over there.
Something that you should look at, but it doesn't tell you to look at, that in that context is not as bad for that person as recommending something that's called hate. Right. But on the other hand, in another context of hiring somebody, and you have, it only recommends good hires, but a systematic bias, and it omits people that would be good hires, but the algorithm doesn't think so, that's a different kind of phenomenon. So it depends on the application as to whether fairness makes sense and what the difference between errors of omission and errors of commission.
100%. The same amount of error mean different things in different applications. So again, back to the question, really depending on the application, we need to understand how people perceive the difference in the errors or the difference in the fairness definitions. I 100% agree with that.
But errors of omission are maybe more insidious because they're harder to notice, and they're clearly a form of censorship.
And I was going to say, I mean, people use different p-value levels. Back when, I don't know, people are still doing this in different disciplines, oh, it's not significant at the 0.05 level or the 0.01 level. That, I mean, I think that when I try to teach statistics to students, I try to point out, what does the p-value mean? Do you care if you accidentally don't see a thing that is happening, or is it better to make sure you do something just in case? And that level that, that's being calculated by an algorithm or a statistical test, it depends on what the cost is. So I like that you brought that up. I think that's, and so I think that you have to tell people that's what it means. It's not just a number. Oh, look, the number was small enough, and talk about in the application, what is it more important to make the commission or omission error in that situation?
I think though, I think the idea of being able to judge fairness in advance is in and of itself complicated. I'm not going to find it, but there's a great line in one of the pieces that I read for this that says, what is the difference between adaptive learning, which instantaneously produces different learning situations for different students in the class, and tracking, right? We thought tracking was an incredibly good idea in the early 70s because it would give the extra attention needed by groups of students who needed extra attention, and it turned out to be a kind of demographic disaster, right? So fairness is not necessarily predictable, and I also like that case, Abel, because it's sort of the opposite of the version that you gave, right, where the data changes and they say the story is the same. Here it's like, we're doing the same thing, but we're really hoping we're going to get a different outcome. So, yeah.
Yep.
So you showed us that article that says that facial recognition is right if you're a white guy. So it's really interesting to think that we think it's fair towards them and unfair towards the rest of us, but it can easily be looked the other way around. And we said that, you know, it's unfair towards white guys, but they are being recognized everywhere in a way. Right. I feel like that's kind of like flip around fairness is really interesting.
Yeah, that's a great point. And that's kind of why I threw off this comment about, do we even want facial recognition technology to be happening at all? Like, I didn't get asked if I want, you know, I mean, I hardly ever post photos on Facebook, but when my family does, it recognizes me, and I'm like, I didn't want that. So, I mean, I think that's, I mean, and I love that, like, most of us said things about interdisciplinary work, right? So, I mean, that is, I mean, I will make a plug for the Science and Justice Research Center, right? Like, that's why it exists, is that people are not even asking the question, do we want this technology, right? It's just that, like, technology is so exciting and people are working on that. And so it's why it's really super cool to be having this conversation, you know, in the, you know, the engineering department or in the computer science department, is because you're thinking about, when you're training people how to do these things, you know, like how to learn how to just like do the computation or how to make a computer do something, you're also training them to think about, is that even a thing people want the computer to do? And that's why you do science with ethics at the same time, not after the fact. And because you're right? It's not just like, well, maybe we all want to be recognized. Well, maybe none of us want to be recognized, but no one even asked that question, you know. So that's, I think that's a great way to talk about that, to flip that around.
And you can think about the job sorting in the same way, right? Maybe it's the best thing that ever happened to those women that they didn't end up in a 95% male, totally toxic workplace, you know? That's maybe not fair, but it might be a good, right?
On that note, let me switch a little bit the topic, but say you were going to say something.
No, I was just going to say, I mean, I think that's interesting to think that it's maybe kind of provocative actually to say that there's something beneficial to these algorithms or these methods which may be inadvertently, hopefully, discriminate, that they point out the structural blind spots our culture has. And so that's great. We can potentially fix them if they're systemic and people want to fix them. But there's also a sinister aspect. Who benefits from this bias? And so the fact that some of these algorithms are encoded into our social justice system, who benefits from mass incarceration, for example, or who benefits from gender discrimination? So, I mean, one thing I'm not sure how this will sound, but one thing I notice is that there's a lot of focus in engineering, in data ethics and data science on like making sure we can tweak the algorithms to fix everything. But it still comes down to people, and it still comes down to politics. And so I think the focus of data ethics should also still focus on politics and policy and people.
Okay, so that's a great segue because one of the topics that you all brought up is the need to have representative samples. Or what a statistician would call a representative sample rather than a biased sample. And the fact that in many studies, particularly in social sciences, what you do is observational studies that typically don't lead to representative samples of the population, and the effect that that has in the algorithms. On the other hand, we have a very big push towards privacy. So one solution to the problem of bias is, well, if we could basically sample everybody, we wouldn't have a bias because we would have a total set. But on the other hand, we have a push to preserve the privacy of information. So those two goals seem in some ways opposite to each other because so there is likely to be bias in terms of who wants to preserve their privacy and who doesn't want to preserve their privacy. So how do we face the challenge between trying to ensure privacy of individuals, but at the same time having methods, and I'm going to start with data first, data that is actually representative that can then be used to create algorithms where at least that piece is not an issue?
I think we've lost the battle to ensure privacy. Maybe that's being cynical.
Yeah, I think one thing I can mention is like, I'm not saying for all fairness definitions, but there's one definition calling for what is so-called statistical parity. That's basically saying it's fair if the decision is independent of the sensitive attributes. If that is achieved, it's fair, but also that means you don't need to report your sensitive attributes because the decisions are going to be independent. And that way, I don't think these are really, there's a tension between the two, there's necessary tension between the two notions. In some way, they can both be improved one way or another.
Well, I mean, I guess what I wonder is there, to go to that question, is there a way to allow data to be, I know that this doesn't happen very often, but so I worked in predictive analytics, and at the company I work at, we give people the option of having their data de-identified from them. So we do statistical models with everybody's data, so we gather data about everybody. And then some people, you can actually correlate that and report on those individuals and look at their data, and those who requested privacy, you can. So I don't know that that's an ideal solution, but that is one practical way that it happens. I like to think that the people who use our software haven't lost the battle entirely.
Right. Also, there's some recent really cool works talking about if you can use machine learning to reshuffle the data, everybody preserves their privacy, but the overall statistical property is going to be preserved. That would serve the purpose. Right? You're still going to learn whatever you want to learn from the data overall, but each individual data points is going to enjoy their privacy. So that's also another possibility.
That's a really good point, because I know there are definitely methods to try to do that.
Like
yeah.
massage the data.
Yeah, like in a sort of systematic way where there's actually, this is actually a very old concept. There's a forest inventory program that the U.S. Forest Service does called the Forest Inventory Analysis Program, and they do things where they they're sampling on private land, and so private landowners don't want people knowing exactly what they have on their, in this case timber, and they do things like swap the plots, and there's a very specific way they do that. And if you want to work with the real data, you can, but you have you go work at a particular office and that kind of thing. And I wanted to raise a related question that I run into all the time, which is that there's this push for open science and open data, and I am totally in favor of that, but I am also in favor of data sovereignty for people whose information has been extracted from them, particularly indigenous people. And I feel like they're both really important ideas, and there can be ways to manage that, but that's all about asking the people who are being asked to give data, having the conversation with them about what is it used for? You can't just, there's a tension there. I mean, you keep asking really hard questions, which is great, because that's what we have to try to address. And this is, again, interdisciplinary. This is you get people, you have to talk to the people who are going to have their data used. And I feel like if people felt we hadn't lost the battle on privacy, and I feel you on that. I know what you mean. If we hadn't lost that battle, then maybe you would be able to make an argument well, if you do this, we're going to use it for this purpose. We're going to, mix it up this way so you can't be identified. I think that's a really important step that has to be there before you could do a method like that. And then there may be ways to do it algorithmically and that might work.
Jenny?
I just want to amplify what's already been made about, what's your point about it kind of matters at what level you ask the question. How do you frame what data ethics is? Is data ethics, is your algorithm fair, or is data ethics, is the purpose of the algorithm fair? At what point do you start asking the question? And that will determine who's in the room, having that discussion too. So, the long-standing question in genomics has been exactly this question of do we include everyone? Would that be fair? Because then we wouldn't be targeting, preferentially targeting people. But if you go down that route, you're kind of presuming that the collection of genomic data, should happen, and there's all kinds of nuances to that discussion. So I think that the discussion we're having here, clarifying what might count as data ethics, and where do you begin the conversation, and maybe needing to back up the conversation 2 steps to ask what are we actually doing? What is the purpose of education? What is the purpose of the criminal justice system? What is the purpose of medicine? What is health? And then if you do that, it means that the conversation we're going to have is going to be really different, and what it means to educate scientists and engineers about this would be really different. The last thing I wanted to say is I don't actually think we've lost the battle on data privacy. And I think that's because, like, what do we mean by privacy is an evolving thing. And I see people fighting that battle on data privacy in the biomedical health records realm. And there are things people are doing to create environments that have different kind of bumps in them along the road, different access points, different way to design the system that provides more transparency about who has access and what's actually going on. I think the point about transparency is really important. I don't think we even know what privacy is. Like who even could say or describe what privacy is? We talk about privacy, we talk about property as if we know what those things are, but we often don't, and they're changing in the midst of these data environments that we're creating. So it's just to kind of, just amplifies points that I've made, but I think to substantively answer the question you're asking, Abel, I think it requires kind of backing up 2 steps.
Thank you. James.
So I want to echo this point about our notions changing. So for the last 10 years, I've taught a class which is technology and social issues, and asking the students to think about, like, you're the computer scientist, you design the system. And one of the topics is this privacy topic, right? Do you want to design systems that enforce privacy, or do you want to design systems that don't allow privacy, right? And this can be argued both ways. And 10 years ago, I could get the students to have a huge fight in the classroom about, like, I don't trust the government, I want to be private from them, versus, oh, there's some value to being able to, right? So, like, which way do we want to have this? I've noticed more recently, in the last 2 versions of me teaching this class, the students come down all on the side of there's bad actors in the world, and in fact, we would like to have some societal oversight over those bad actors, and building systems which allow complete privacy is maybe not what we actually want to build. And I've seen a huge demographic shift over the 10 years of what the students in our classrooms think about. Like, where do we want to end as a society? So I think that it's very interesting that you're making this point that it's not, like, there's not a goal. Right? This is a societal defined goal that sort of shifts over time about what do we want to have. So maybe we've lost the battle, and they all think that, like, privacy doesn't matter anymore. I mean, maybe that's the reason. I don't know. But there's a change in how they feel what we want to have.
Yeah. So Shell, and then we come here.
Okay, I'm going to make a strong point, and I'll make it quickly because I have to go on to 2 minutes to teach data management. And Scott McEwen about 20 years ago, when he was CEO of Sun, said there is no privacy, get over it. I'm not sure he was right then, but he is right now. Any data that is gathered and any data that is stored is going to end up finding its way into all sorts of different combined uses. And the ways that things can end up being put together by a variety of different algorithms that use things about you that you wouldn't expect and end up being immense. And so I would argue that the only way to ensure privacy is to ensure data isn't gathered. But even if we try to be ethical about how we end up storing the data and using the data together, there are going to be bad actors out there who can write their own algorithms or use ours in ways that we haven't figured out to be able to do things. So the question is, how do we end up in a situation in which there's a data algorithm anti-privacy arms race? How do we end up coping despite the fact that this thing is totally unsolvable, but as engineers, how do we solve it anyway?
Good point. So, yeah, I think there's again, I mean, I don't know if I completely believe this, but I do sense in my own work and the work of engineers and the work of people working in data ethics, a naivete that thinks if we tweak the algorithms, we'll somehow solve problems. It seems like there needs to be a discussion, as many people have mentioned, with policymakers. We need to decide as a society and think about the shifting target. And regulation is useful potentially, but then we also have a drive to not be regulated. We have a drive for transparency at the same time we have a drive for privacy. So I guess I don't think that just designing better and better algorithms or better and better definitions of fairness will ever solve the problem. It's a larger, more societal problem than that.
Okay.
So about 6-7 years ago, we were all very surprised that suddenly we have a field called data science. We have a field of data science. Nobody knew where it came from. We started looking at all of that industry, or they've been working with astrophysics data for 20 years and learned some Python. So, and I'm a computer scientist. I teach database classes a lot. I teach some machine learning. So I was as surprised as everybody else. That's something that I consider doing as part of my profession. So there was some things with completely different experiences with. So what we've done in the past 5 years is we sort of regrouped and we started saying, okay, we have to, like, if you want to be a data scientist, you don't need a PhD in chemistry. We actually can educate you right here, right now, starting with your year 1 in college. So I want to ask this question. So based on what we've discussed right now, how can we, or what should we be doing with our undergraduate students studying data science? What should we be teaching them? What should they be learning specifically in the coursework that we're offering?
Seems like a foundation in ethics would be a good idea.
I don't know if it's like impolite to say this, but UC Berkeley has just graduated their first round of data science majors, and they have folks who they have ethics classes as part of that education. So that's, and I'm sure Berkeley's not the only place doing that, and I think Santa Cruz would be awesome at doing that. So, you know, science and justice, there it is again.
And what I hope we'll do with them is put them to work on the questions that we're asking today.
Right.
I mean, I don't want to put them to work on theoretical questions. I want them to be asking questions about what's happening with their own data and weighing the pros and cons, right? Because I think part of what we're talking about is if we have total privatization, then any notion of data for social justice goes out the window, right? So we're going to have some identification if we're going to use it for social justice. So socially responsible versus social justice, I think those are the kinds of questions that a student should be studying in a data science degree so that they don't get confronted with that question and go, wow, that didn't occur to me that that would be a problem, right? Because I think what we keep talking about today is, you know, the barn door swinging in the wind and trying to imagine that we could get ahead of the big questions that we are now kind of not ahead of.
I do get a sense that many professors in computer science and in engineering and across campus are thinking about these issues and do incorporate them into their curricula. I know there's efforts by people here to kind of codify that and formalize and create specific classes. Some already exist. I don't think they're mandatory, but that is something I know I'm doing, and I think all the faculty in engineering are thinking about.
So we here value privacy, individual rights, ethics, but we're not the only ones in this world. And in China, there's an effort called social credit scoring, which is using data analytics, artificial intelligence to actually control the population and make sure that the ruling elite stay in power. So how do we make sure that whatever we create is not abused by other people with other ideas? How do we compete in the notion of world opinion with developing countries that says this is the way that you should use data science in order to uplift your population rather than using data science in order to be able to control the population? Are there competing worldviews that we're dealing with?
I don't mean to totally trivialize what you just said, but we do have something called the SAT, which suggests to me that we're not entirely squeaky clean when it comes to the notion of social engineering through data algorithms. I mean, how is that different from any other kind of sorting machine?
Yeah, I just want to mention we also have a credit score system here, and it's pretty messed up. Again, I used to have a slide, but I removed it due to the time limit. Many credit card applications, like loan application and financial service, they rely on the credit score. And the credit scores, if we break it down according to especially the races, it's very miscalibrated. Meaning, if you just based on the credit score give a uniform decision making, it's not going to protect the difference between different groups. So my point is the credit system is this credit score system is used in many applications. We just need to be careful. When we are making up the scores or when we are using the scores, we want to add the societal constraints. So I think it's a useful system, but just don't want it to be misused, as you mentioned.
So Warren.
I think as we consider data ethics, it is worthwhile to remember how we're calling more and more things data. So originally, if we go back a couple hundred years, the only things that were called data were the things that one would not argue about. It is the given in the original Latin. So Euclid's proofs in Euclidean geometry started with data. The other things that were called data were what were God-given, so God-given truths. That was it. So as we've gone forward in time, we call more and more things data. And this becomes something worth considering right now, because if this data science is primarily about sorting populations, which is what the origins of statistics and probability shows. I mean, if we look at that, starts in the 18th and the 19th century. One of the main applications is to sort people into the normative, the non-normative, the deviant, the good, the criminal, and versus, let's say, we're dealing with data about astronomy, where we're not sorting people per se, we're doing something else. So I think it might help our thinking about data and ethics if we can distinguish one kind of data from another, and primarily the data about people versus data that's not about people.
Just a quick thing. One thing I always say when I teach data visualization is that I'm actually more interested in system visualization than data visualization. And the data is meant to give insight into complex systems. And really, reasoning about those systems is the point, really, of science and of data collection in general. And so maybe focusing not just on the specific data and the data transformations, but on how it's used, thinking more holistically, is an important thing that data ethicists and data scientists should be doing.
I think you're right, Warren, and I want you to be more right than you are. But if you think about the first example that I used of counting the students in the library, and then counting the students using what kind of devices in the library, and then counting the students watching YouTube in the library, we've gone from a relatively inert kind of tracking with exactly the same technology. Nothing about the technology has changed in that arc to technology that's open to much more pernicious uses. So I don't know if it's about people versus not people, because about people can mean a number of different things.
Well, I don't know if there's a hard and fast distinction, but it seems like keeping track of whether or not we're trying to sort people ultimately is an important distinction here.
Right. I think tracking the data is going to help you remove the unfairness at the very beginning, but still, even the data is not coming from people, you could have bias when you're doing the training and deployment. So.
Okay, so we're out of time, so let's thank the speaker and the audience for very good questions. We have a 15 minutes break, and then we'll have our keynote speaker here for